All right, today is June 15th. First question asks us to find the zeros of an equation. You can use either method. What they mean by either method is you can either factor this question or you use the quadratic formula. We're going to try to factor it. If that doesn't work, we'll use the quadratic formula. So we need to find the factors of the first term and the last term. And you know that the products need to add up to -3. If you look across, they quite easily work. 2 times 1 is 2. 1 times 5 is 5. And if the 5 is negative, we're going to add up to -3. So when I go to put this into the bracket, I take my first terms, and I have to put the second terms in opposite brackets that they're multiplied by. So since the 2 was multiplied by the 1, the 2 and the positive 1 have to go into opposite brackets. The same idea as with the 1 multiplied by -5, the 1 and the -5 have to go into opposite brackets. It's equal to f at x. Now, the question says to find the zeros, which are the x-intercepts. To find an x-intercept, we have to set y equal to 0. So we're going to move this up here. Y, or f at x, will be 0. 2x minus 5, x plus 1. We're going to split this equation. We're going to have 0 is equal to 2x minus 5, and 0 is equal to x plus 1. X is equal to either -1, and then when we divide, we get 5 over 2, or 2.5. So our two zeros are 2.5 and -1. To find the axis of symmetry, we need to add our x-intercepts together and divide by 2. You guys remember the formula was r plus s divided by 2? So we take our first x-intercept, 2.5, plus -1. We divide them together. That's going to get us our axis of symmetry. 1.5 divided by 2. Is that 0.75? Equal 0.75. So our axis of symmetry is x is equal to 0.75, or if you left it as a fraction, could have been 3 over 4, something like that. Find the vertex of the parabola. The axis of symmetry is already our x value for our vertex. So we already have the x value at 0.75. I need to plug that x into either our factored form or into our standard equation. I'm going to put it into the factored form to solve. So our factored form was 2x minus 5, x plus 1 is equal to f at x. I'm going to substitute in for our x's. 2 times 0.75 minus 5, 0.75 plus 1. 2 times 0.75, 1.5 minus 5, 1.75. Who has a calculator can help us here? 3.7, is that 3.5? Oh, negative 3.5, thank you. And finally, what is it going to multiply to? Negative 6.4? Beautiful. Okay, so our vertex is 0.75. Is that right, Christian? Oh, 6.1. Negative 6.1. So we have our x and our y value of the vertex. So that would be putting everything together. Starting in standard form, moving to factored form to find our x-intercepts, and finding the axis of symmetry, which is also the x value of the vertex, and then plugging that value into either the factored or standard form to find the y value of the vertex. All right, question 2 on part C. This is actually not a real triangle. These numbers are wrong. So, I'm going to redraw this triangle. Imagine it is the same. Is mine different from yours? No, it says 37. Oh, okay. Okay, so we're going to redraw this. We're going to redraw this triangle. It doesn't exist, this triangle. Okay? That's roughly it. We're going to say this is 37, this is 11, and this is 35. Okay? So I've redrawn the triangle because the other one doesn't work. Doesn't exist. And I would like you guys to find side B. So if we're looking for side B, which formula do we have to use? You know, not an angle triangle. Cosine law, good. We need to use cosine law to solve this triangle. So remember, we always rename our triangle. I'm going to call this A and A. We're going to call this angle B and side B, and we're going to rename side B, C, and C because we're used to setting them equal to C. So our formula, C squared equals A squared plus B squared minus 2AB cos C. Okay? We're going to plug these values in. We're looking for side C. Side A is 37, and side B is 11. 2 times 37 times 11, cos 35 degrees. Okay, so we're going to solve these numbers here. I'm going to do 37 squared, and I'm going to add it to 11 squared all in one step on this calculator. So, that becomes 1,490. Subtract it by 2 times 37 times 11. And that also is multiplied by cos 35. Okay? I put cos 35 in brackets because I want the calculator to calculate that first and then multiply it by 11, 37, and 2. So our number becomes 666.789. We're going to take 1490 and subtract that answer from above. It's going to be, and don't forget the C squared. C squared is equal to 823.21, and it goes on. We're going to square root that answer. Turns out that side C is equal to 28.69 meters, units? It's going to be units, so I don't think we have meters or anything. This question, you could round it up if you want. It's approximately either 28.7 or approximately 29. Either are fine, but make sure you give me one exact answer. You can round after if you like. Okay, question 3 says, Mr. Belcastro has a LeBron James rookie card. He bought it in 2007 for $200 on eBay. Doesn't matter, I could buy it a different year. He estimates that it will appreciate. What's that? Okay, we said it is estimated to appreciate in value 5% each year. So, though this looks like financial math, this is technically a growth formula, which we learned in Chapter 7. If you guys remember, is that right, 7? Yeah. Our growth formula, we use the letters P and O and P and N. P and N was representing we use the word population, but can also be used for growth rate, okay? So we're trying to find out how much this will be worth in a later year. P and O was the original price or how much it was worth. R is our growth rate, and N is the number of compounding periods. So how much will the card be worth in 2020? Well, if I bought the card in 2007, I subtract the 2. That means there'll be 13 compounding periods because it appreciates 5% each year. So our P and N is equal to the, how much should I buy this for? 200? Could buy Xbox. 200 to the power of 13. So 1.05 to the power of 13. Okay, we did 105 to the power of 13. 200 times that number. This card will be worth $377.13. To figure out how long it'll take for it to double in value, we know it was originally worth $200. That means they want to know when it'll be worth $400. Our growth rate is 5%, and we need to isolate N. So I'm going to divide both sides by 200. And I'm going to estimate for N. We're going to trial and error to figure out 105 to what power, so how many years from now, before 105 reaches 2. So we already know that 13 was too low. We'll try 15. Oh, 15 is already too high. With N is 15, it is equal to 2.07, so let's try 14. 14, 1.97. So after 14 years, so between 14 and 15 years, the card will double in value. Okay, question 3A you don't have to worry about. We didn't cover Chapter 8. We can move on from that one. No, you won't have any financial math questions. Okay, I don't think we need to calculate right now. Okay, consider the function y is equal to 3 sine x plus 270 minus 4. Graph one period. Include a graph for each step. So 3 steps in total. Label your axis. Label your graph with this equation. Make sure to include 5 key points in one period and the approximate numbers on your axis. So, let's say this is our y-axis and our x-axis. 90, 180, 270, and 360. This will be 0. They told us to only include one period, so I only need to include between 0 and 360 degrees. Okay? We're going to say that this is 1, negative 1. It tries to include 3 steps in total. Yeah, 3 in total. So what we'll do is we'll go right to the first step, so we only have to include 3 different graphs or waves. We're going to do the first step will be a change in amplitude. So instead of going up to 1, the amplitude is going to go up to 3 and go all the way down to negative 3. So we start at 0, 0. That doesn't change. Our first point at 90 is going to be all the way up at 3. 180, we're going to cross the x-axis again. 270 will be at negative 3, and 360 will again be at 0. So this is our first movement. This is our amplitude, or our A, that's changed. So that's when we've dealt with our A. That's our first movement. Second movement we'll deal with is shifting the graph to the left 270 degrees. So if I got to switch this 270 degrees, I'm just going to take each point and move it to the left 270. In that case, that'd be 3 steps. So we're going 1, 2, 3. From there, it would go down to 3. This one goes back 3, 1, 2, 3. So I only have 2 points in this period. What I can do from there is I can just continue the graph if I'm not sure where it would go next. So since this is rising upwards, the next step at 180 will be at 3. At 270, we'll be back down at 0. And at 360, we'll be at negative 3. So almost like we've just drawn a mountain. And finally, our last movement is negative 4. So I have to move this entire graph down 4 and draw a very good scale. 4, 5, 6, 7. So this graph, each of these move down 4 units. 1, 2, 3, 4. 1, 2, 3. Say this is 4. 1, 2, 3, 4. 4 and 4. So if you drew the scale properly, our final graph is in green. It's been shifted down 4 units to the left 270, and it has a new amplitude of 3. In the question, it asks you to only graph one period. Where is it? Oh, there you go. Graph one period and include 5 key points. So let's put our 5 key points of our new graph right now. We have 0 and negative 7. I have 90 and negative 4. 180 and negative 1. 270, negative 4. And 360 and negative 7. Those are our 5 key points. I know it's kind of in the way of our domain. Our domain, because we only had the graph one period, we have to show the domain, so I'm going to write it over here, as only one period. So x is all real numbers such that it's between 0 and 360. It doesn't go on forever because we only graphed one full period of this. Our range goes from negative 7 all the way up to negative 1. So y is between, it's greater than negative 7, less than and equal to negative 1. The equation of the axis. So that's the middle of it. If you can't tell by looking at the graph, what you can do is you take the 2 highest points, the 2 extremities, so the trough and the peak. So we're going to take negative 7 and negative 1, and we're going to subtract them. When you subtract those 2, we'll end up with negative 6. Is that right? And if we divide by 2, it should be a negative 4. Sorry. We have to add these 2 numbers. When you add those two numbers together, we would have negative 8. If you divide that by 2, it'll tell us our equation of the axis, which is at negative 4, which makes sense. It goes right through the middle of the sine graph. Our equation of the axis is then x equals negative 4. Our period is 360 degrees, and our amplitude is already in the question, and it's 3, so our amplitude is 3. Okay, part D, show your work in the space provided. It says a function blah gives the approximate height, h in meters, of a thrown football as a function of time, t seconds since it was thrown. What is the max height of the ball? So this is a quadratic equation. I want to find the maximum height of the ball. I could factor to find the zeros, then find the axis of symmetry, then plug it in to find the y. Or I can complete the square, put it into vertex form, which would be the fastest way to find the vertex or the max height. So we have the equation h is equal to negative 4 t squared plus 20t plus 3. To complete the square, I'm going to take out the number in front of our squared variable. And I'm going to take it out of the first two terms. Think of that as like almost like a common factor. So I take negative 4 out. I'm left with t squared minus 5t, because I divide negative 4 by 20t, plus 3. Once I'm done that, I'm going to take our new b value, which is 5, and plug it into b divided by 2 squared. So I know what number to add and subtract inside the brackets. So remember, when you're dividing, only divide by the coefficient in front of the squared variable. Don't take out a variable with it. We only want negative 4 on the outside. So we take our our negative 5. Negative 5 divided by 2 is equal to negative 2.5. And negative 2.5 squared that squared wrong. Should be positive. 6.25. It's 6.25. So we're going to add and subtract that number inside of these brackets. So we have equals negative 4 t squared minus 5t plus 6.25 minus 6.25 plus 3. Extend the page. I'm going to rewrite it so it's a little easier to read and that stuff's not in the way. Okay, so in order to make a perfect square trinomial, I only need these 3 terms, which means I need to move the negative 6.2 to the outside of the brackets. When I move it outside the brackets, I have to multiply by the number in front of the brackets. So I'm going to have to multiply negative 6.25 times negative 4. So we'll be left with just the first 3 terms inside the bracket. And then when we go to move it outside the bracket, multiplied by negative 4. Is it 25? All right. 25, right on the dot. Positive 25 plus 3. Next step is we want to factor the brackets. I'm going to take the square root of the first term, square root of the last term. We're going to put it into one bracket with just 2 numbers. The square root of the first term is t. Square root of the last term is 2.5. And I'm going to bring down whatever sign is in front of the second term. So because it's negative, we're going to bring down a negative. And we leave a square at the top of the bracket. 25 plus 3 is 28. This is now vertex form. This is my x value and my y value. So if I was to write the vertex, Because this is negative, my actual vertex is positive 2.5 and 28. So the max height of the ball is 28 feet, meters? What do they do it in? Meters? Oh, wow. Meters high. Question 2 is financial math. Don't have to worry about it. Very last question. A communication tower is fixed to the top of a building. So let's do our building. This is from our Chapter 5 test.
Sir, is the building leaning or is it straight?
It's not leaning.
Well, there's also going to the building.
Okay. We have our communication tower. Let's say that it looks like a satellite. Okay. So we have a communication tower. It says that from the base of the building to a point is 10 meters away. The angle of elevation to the top of the building is 60 degrees. So here's the top of the building. That's 60 degrees. And it says from that same spot to the top of the tower, 68 degrees. So we have two right angle triangles. That angle is 68 degrees. What is the height of the communication tower? So they're just looking from here to here. That's what they need to know. Height of the communication tower. In order to solve this, I need to find the height of the building and the communication tower, and the height of just the building, and then subtract the two. So this is a right angle triangle. Of the angles we have the adjacent, and we're looking for the opposites in both. So we're setting up tan ratio. Tan 60 is equal to opposite over adjacent, which is 10. So this is for the height of the building. I bring the 10 over, it is 10 times tan 60 is the height of the building. $17.32. So the height of the building is apparently 17.32 meters. The next one we're going to figure out is the height of the building plus the satellite tower. That angle is a 68 degree angle. So tangent 68 degrees is equal to the opposite over, and our adjacent is still 10 meters. Same idea, we bring the 10 over and multiply this time by tan 68. Tangent 68 times 10, 24.75. What did I say, 24.75? So, we know that this entire height here is 24.75, and the height of just the building is 17. But the question asks us, for the height of the communication tower, this part here, I need to take those two values and subtract them. 24.75, subtract 17.32, 3, 4, that's going to be 7. There you go. So the height of the communication tower is 7.34 meters tall.